Our lecture today is on the soil test. I'm Alec Kovalevsky, your instructor. This is Plant Nutrition Hort 316. So let's learn all about the soil test. Okay, so today we'll cover how to properly collect a soil test, what kind of analysis you should be looking for, and then how to interpret results of soil tests. So let's talk about proper collection of a soil test first. All right, some tools that you will need for collecting a soil test. We want to use a plastic bucket rather than a metal bucket because the plastic bucket will not have nutrients that are found in the soil that could be reported on the soil test. A metal bucket could have some of these nutrients, for instance, any kind of metal plating that could chip off of a bucket could end up in the soil test and then provide us with strange results. So we want to use a plastic bucket, not a metal bucket. Okay. We're going to use some kind of tool to dig soil up out of the ground. So you could use a shovel, you could use a soil probe or a trowel, or even a little hand tool like a hori-hori here in the picture on the left. So all of these are great options for collecting soil tests, a shovel, a hand trowel, or a hori-hori knife. Okay, and then here's an example of a plastic bucket. And then finally, we need something to put our composite sample into to send on to the laboratory for analysis. So this could be a small plastic bag or paper bag. Okay. And you see in the picture on the left over here, I've got some Ziploc bags, Ziploc sandwich bags, which I typically use for my soil tests. Okay, so steps to collecting a soil sample now. We're going to be collecting subsamples, multiple subsamples from an area. So in the picture on the left there, that is me collecting soil samples from a athletic field in Gresham, Oregon, at the Gresham High School. And I'm collecting multiple samples with the soil probe down to a 4-inch depth. I'm doing, I think, 10 soil samples per sports field here. So let's back up just a second here. You're gonna collect multiple subsamples from a site. When you collect a sample, we typically remove the organic matter off the surface. So for instance, in my field, turfgrass management, we often have a lot of organic matter. The grass blades and the thatch of the turf at the soil surface there. So typically we peel that off the top of the sample because we're interested in the nutrients in the soil, not in the plant itself. So often we'll remove organic matter off the surface, put the samples in the plastic bucket, and we want to collect 10 to 20 samples per acre, and a athletic field is right around an acre in size, so we're going to collect 10 to 20 samples per athletic field. Okay, we're going to mix the samples together in the bucket, the 10 to 20 subsamples, to make a composite sample mixture. And then we're going to take 100 grams of that composite sample and bag it up to send it on to the laboratory for analysis. Okay, so the goal here is to get about 100 grams of soil to send along to the laboratory. Okay, and this is what the sample should look like at the end here. You've got all these different subsamples that you put into the bucket together. You can use your spade or your hand shovel or your hori-hori knife to chop these samples up and mix them all together. And then you take your 100 grams of this composite and bag it up and send it along to the lab for analysis. Okay, so here you see a great step-by-step drawing on the steps I just covered. You know, in the top left there, you see they are digging the sample out of the soil. They're showing the sample coming up out of the ground. In the previous slide, I talked about sampling to a 4-inch depth. That's on turfgrass because turfgrass is a relatively shallow rooted plant. So depending on the rooting depth of your crop, let's say if you're growing a tomato plant and you want it to have a rooting depth of 12 inches, you should take the soil sample to a 12-inch depth. So just keep in mind that your sample collection depth should be consistent and it should correlate to the rooting depth of the intended crop that you're using. Okay, so in the drawing here, we're progressing on. You see that they're also removing the organic matter or thatch from the top of the soil sample. They're putting it in a bucket, and then they're removing any excess or remaining soil. And then they're doing this 10 times in this lawn here to make a composite sample. They're using the knife or the hand trowel here to chop up the sample and mix it together, and then they're putting it into a bag that is ready to send to the laboratory for analysis. Okay, and as we talk about agricultural production, if you have a large farm with different crops, you should be doing different samples per cropping area. So in the picture here, this was a picture provided by the soil testing laboratory at OSU. You see they have 3 different areas defined. Area A has some, looks like fruit tree or nut trees growing there. So they're going to collect samples for analysis from area A. They've got a lawn here in area B. They're going to collect a separate sample for area B. And there's going to be all different rooting depth collections for these crops. The area A, which is the tree, will have a much deeper collection depth to correspond to the deeper roots of the trees, while area B will probably be at a 4 to 6 inch depth, correlating to the depth of the turfgrass. And then area C in the top right here is a annual field, probably something like corn, which is growing just in the summertime. And we're going to again collect a separate sample to the required depth of a corn plant for that 3rd sample. But the take home here was collect multiple composite samples for different areas on your farm or areas that are growing different types of plants. Okay. And here you see a couple soil samples I had collected this year for some of the research that I'm doing. And I've come through and labeled each individual sample. I like to put a plot number or some kind of identifier on there, as well as the date that it was collected. So all of these samples were collected on October 22nd of 2020. And then I've also got the plot number listed on the front of the soil sample. 1, 2, 3, 4, 5 in this case here. Okay, so we've got the sample collected, we've mixed it together, formed a composite, and then filled up these collection bags, and we've got them ready to send to the laboratory for analysis now. Okay, so let's talk about what kind of analysis we should be requesting from the laboratory. And for this part of the lecture, I wanted to highlight the OSU Soil Testing Laboratory. It's within the Crop and Soil Science Department. It used to be called the Central Analytical Laboratory, but in the last month or two here in fall of 2020, it has been changed. So the name is no longer the Central Analytical Laboratory, but it is now the Soil Health Laboratory. So if you were to Google OSU Soil Health Laboratory, you would find this. Click on that, and then within your options across the top here, we're going to click on Soil Test. So click Soil Test once you've found the OSU Soil Health Laboratory. Okay, once we get to Soil Test, we're going to click on this button down here that says Soil Sample Submission Form. So remember, click on Soil Test first, and then it'll give you the Soil Sample Submission Form. You'll see also highlighted in black is plant testing. So in our lectures, we've talked about tissue analysis for a variety of different crops, particularly grape and hazelnut. So you can use tissue testing as well to determine how much fertilizer is required. So there's an option for plant testing as well. But today we're going to highlight the soil testing route here. So you clicked on soil testing, it brings you to this page, soil testing at OSU. You click on this soil sample submission form, and then it's going to bring you to the following PDF. So I took this PDF and I cut it in half. So you've got the top half on the left and the bottom half on the right. It's just a single page document. For this document, you're going to fill out your name, organization, address, contact information, etc. And then I went through and kind of put these blue squares around areas that seemed like important analysis for Western and Eastern Oregon. Okay, so the top one here, I put a checkbox next to. I would imagine that this is probably the most common soil test we're going to have people requesting in the state of Oregon. This is a Western Oregon basic soil test. So you'll see some of the data included in here include pH and lime requirements, as well as NP and K requirements, magnesium, calcium, and organic matter requirements in the soil. Okay, so that was for your Western Oregon basic soil test. For folks that live in the high desert area of Eastern Oregon, you've also got a Eastern Oregon basic soil test, and you see that the results are a little different. Now you've got pH. We often are not going to see a lime suggestion for Eastern Oregon because it's going to be an area of high soil pH, and we typically don't need to apply lime to raise the soil pH when it's already alkaline, which is common in Eastern Oregon. You'll see EC values as well as nitrogen, phosphorus, potassium, calcium content, magnesium content, and organic matter content. So you see some slight variations when we move from the Western to the Oregon basic soil, Western Oregon to Eastern Oregon soil basic soil test request. Okay, so those were your first 4 options over there. You can do a basic soil test, or you can also do an advanced soil test, which now starts to include some of the micronutrients as well, such as copper, zinc, iron, and boron. And I think we talked about this in an earlier lecture. I often see boron deficiencies in Western Oregon, so it's very advantageous that you see it there in the Western Oregon Advanced. Okay, so the soil test is intentionally targeting common deficiencies in our area. The Eastern Oregon Advanced also has added copper, zinc, iron, and boron in as well. And then over here on the far right, I see some other things that I think are interesting. If you wanted to pay a little extra, you could also get a physical analysis to determine the exact texture at your location, particularly the sand, silt, and clay concentrations. We can also do a web soil survey to determine this, but if you want more accurate or precise geographical data, I would do a physical soil assessment rather than a web soil survey. Okay, and then on the very far right over here, you see options for various micronutrient extraction packages. If you feel that the data on the left over there with the basic analysis or the advanced analysis is missing something, you can request some specific details on the far right over here in terms of micronutrient analysis. Okay, so those are your soil tests and the things I think are important to look at within your different testing options. Your Western and Eastern basic and advanced soil test, as well as physical assessments if you think that's important, and then finally some extra micronutrient analysis on the far right over here. Okay, so let's move along. Okay, we talked about collection methods. We talked about what analysis to request. Let's talk about interpreting the results now. Okay, so all right, here we have a sample soil analysis that I had done through the A&L Western Agricultural Laboratories. Some important things to look at in this set of results is First, across the top here, we see our different soil test results. You've got the phosphorus weak bray, suggesting that we have 32 parts per million of phosphorus. You see another analysis here for phosphorus, this time using sodium bicarbonate, and this is actually an Olsen soil test for phosphorus extraction. Then you see the potassium levels being 120 parts per million, magnesium being 119, calcium being way up at 962, sodium at 49, and sulfur at 20. We're not seeing any micronutrients here because this was a basic soil test and I did not request micronutrient analysis. Some interesting things to point out here. In the A&L Western laboratory results, they include sodium as part of their basic soil analysis, and this is because they're more interested in sodium as a developing toxin in the soil, not necessarily an essential nutrient. So often we'll keep an eye on the sodium levels to see if it's getting excessive, and when it does, we can apply products to then flush the sodium out of the soil, which we're going to talk about in our final lecture for the term when we discuss sodium or sodic and saline soils. Okay. Other things to kind of focus in or point out. Let's turn our laser pointer back on. So some other things to also add or think about here. Our phosphorus results, we have 32 parts per million according to a weak bray analysis. And if we look down here on the bottom chart here, we've got different extraction methods: Morgan, Bray 1, Olsen, Malick 1, and Malick 3 for phosphorus. And you see the Bray 1 extraction method suggests that we need 16 to 30 parts per million to be within the optimum range. So that would confirm with this soil test that says 32 parts per million that we are in the excess of phosphorus. We don't need to make a fertilizer application because we have excess phosphorus according to the weak Bray 1 analysis. If we take a look at the sodium bicarbonate extraction method, it says 21 parts per million. This is actually the Olsen extraction method. So this extraction method would suggest, if we compare it to the table on the bottom here, that we're kind of in the optimum range for Olsen phosphorus extraction method. The interesting thing that's not provided in this soil test result is the A&L labs have not provided a Morgan extraction method for phosphorus, which is the suggested extraction method for the northwestern United States, particularly Western Oregon. So that's a little concerning that our extraction methods are Bray and Olsen and not Morgan. Okay, so you know, it's important to make sure we're using the right soil test when looking at the results and comparing the results to the right ranges. So as I said earlier here, you see different ranges for phosphorus according to the extraction method. We're pretty confident here that our phosphorus is in adequate ranges, but one thing to consider is again, the soil extraction method was not the Morgan method, which is suggested for the Northwest. Okay, if we move on a little past that, let's go over to the potassium and magnesium and calcium. You see that potassium is at 120 parts per million. According to this soil test, that would suggest that it is in the medium range, and magnesium here, 119 parts per million, again would suggest it's in the medium range, and calcium is way up to 969 parts per million, verging from medium to high in terms of soil test results. So some interesting things also to look at is on the bottom of this soil test result, we have requested soil fertility guidelines for turfgrass, okay? And it's suggesting 3.5 pounds of nitrogen per 1,000 feet per year, okay? And that is not associated with the soil test, that's just a general recommendation associated with typical turfgrass needs. And then the interesting thing is the soil test results from this lab are suggesting an application of phosphorus at 2 pounds per 1,000 feet per year. and potassium at 2.5 pounds per 1,000 feet per year, which I think is a little high, particularly when you consider that the phosphorus and potassium levels here are, phosphorus is right on the edge of medium to high, and potassium is in the medium range. So one thing to consider here is when you do a soil test, you can request laboratory results or suggestions, you can request laboratory suggestions, but I think you're much better to go back and look at the extension documents, for instance, like the extension documents we've been studying in this class when determining how much fertilizer you should apply. Okay, so we'll work our way through to some more soil test results, and we'll discuss referring back to some of these extension bulletins and some of these future soil test results. So let's move on to the next one. Okay, so here we see another A&L Western Agricultural Laboratories soil test results. It's similar to the last one we saw. Again, you've got two different methods for phosphorus extraction, weak Bray 1 and the Olson method, but not the Morgan method, which these two are suggesting the phosphorus levels are at high, approaching very high. We see potassium at a medium level, calcium up at a very high or high level, and then sulfur in a medium level approaching high. Okay, and again, across the bottom here of this soil test result, you see recommendations for turfgrass. Again, they're suggesting 3.5 pounds of nitrogen per 1,000 feet. This time they're suggesting 1 pound of phosphorus per 1,000 feet because the results were a little higher, and potassium at 2.5 pounds per 1,000 feet. Okay, and again, just think back and refer this to some of our previous results or previous exploration in plant nutrition. And again, we should try to find a Morgan soil test for northwestern soils rather than a Bray 1 or an Olson extraction method. Okay, so let's again move on to another soil test. Oh, so excuse me. In this instance here, as I said previously, it would be great for us to go back and instead of necessarily following the recommendations in the soil test, which are produced by this lab, we should take these values and cross-reference them with the local extension publications. So here you have on the far left a Turfgrass extension publication on soil testing that I produced. You have the hazelnut extension bulletin or the vineyard extension bulletin that we've been working on throughout the term. And then on the right here, you see the blueberry one. And we've also been doing work on a hazelnut extension bulletin as well. So all four of those could serve as great reference material when comparing your soil test results to what's available or suggested for fertility rates in extension material. So with that in mind, these are the results that come from the Turfgrass extension bulletin here. And that turfgrass-based extension one would suggest that the phosphorus levels here, 16 to 30 parts per million with the Bray 1 and 12 to 28 parts per million for the Olson, these levels are much higher than that, 48 compared to the 16 to 30 and 30 parts per million compared to 12 to 28, which would suggest that phosphorus is not needed, which is different from what this soil laboratory suggested to us. Okay, so again, I would compare your extension recommendations to what is actually found in the soil test. If we move along here now, we're looking at the blueberry soil test results or soil test recommendations, and within our blueberry extension publication produced by Oregon State University, it's saying in our soil test, if our Bray extraction method for phosphorus identifies 26 to 50 parts per million, we should apply 0 to 40 pounds of P2O5 per acre. Okay, so that again differs a little bit from what the recommendations in the A&L lab testing results were. I know the crop says turf here, but let's just assume that the crop was labeled as blueberry and they had provided the same recommendations. So they're suggesting a pound of P2O5 per 1,000 feet. That pound of P2O5 per 1,000 feet translated to acres or converted to acres would be 43 pounds per acre. So it is higher than what the Blueberry Extension Bulletin would suggest. So again, the take home here was take your soil test results, compare them to the recommendations that are provided in the local extension bulletins, specific to the crop that you're working on. And Oregon State has several of these for all kinds of different crops across the state. Okay, so that concludes our lecture on soil testing. We talked about the collection methods, particularly about using a plastic bucket, collecting 10 to 20 samples per location, mixing those in the bucket, and then putting them in a bag after removing organic matter from the soil surface and sending it along to the laboratory. For laboratory analysis, we talked about using the soil health laboratory on campus here at OSU. We covered exploring a Western Oregon basic or an Eastern Oregon basic. And then you also had advanced versions of those soil tests. And then down here, we also had physical analysis and various micronutrient packages that we could explore as well. Okay. And then in terms of soil test results, once our lab identifies the various levels of soil nutrients such as phosphorus, potassium, calcium, and magnesium, we should then reference that to the local extension publications rather than blindly following the results provided by the soil lab. So I would challenge you as a scientist to go and find these references that are specific to your crop and then make your application rates according to those extension recommendations. And again, don't just blindly follow the results provided in the soil test lab. Do some exploration. Look what material is available for your specific crop provided by Oregon State University or your local extension office. Okay, so that concludes the lecture on soil testing. I will talk to you all again soon.